Welcome to Heavy Networking, the flagship podcast of the Packet Pushers Podcast Network. I am Ethan Banks. Now, Drew Conroy Murray is not here today. He's going to be back very soon, but you could follow us both on LinkedIn, where we help you keep up with what's going on in networking. Today's podcast topic: how do you architect a secure access service edge that is SASE? How do you architect a SASE platform to maximize performance and uptime? Now, think about this. If you had to provide a complex service to millions of endpoints distributed across the planet, how would you do it? Would you do it yourself, maybe with dark fiber and your own server stacks and cloud services? That is a heck of an infrastructure commitment, especially at planet scale. So maybe you wouldn't do it that way. Well, sponsor Palo Alto Networks opted to go all in on a multi-cloud approach for its Prisma SASE offering, and we're going to discuss the why and how of this architecture with our guest, Christian. Christian, I'm going to try your last name here. Raducanu. Am I close? Was that close?
You're close enough. I would say Raducanu, but we'll
It's Raducanu. See, Raducanu. There we go. Well, Christian is the Senior Director of Product Management, Cloud Delivered Security at Palo Alto Networks. Christian, nice to have you on the show today to get into the nuts and bolts of architecture, which I love these conversations. And you guys are pretty open about what you're doing there. So this is going to be a fun discussion. Now, I set this up that we're going to be talking about your Prisma SASE platform and how you guys architected that, what's really going on behind the curtains. So, but before we get to that part of things, would you remind us what the heck this service is so that we don't get lost in some of the product name jargon and so on as we chat?
Yeah, absolutely. So we're talking about Prisma SASE, which is an integration of Prisma SD-WAN, which is our SD-WAN offering, and Prisma Access, which is our SSE, another acronym, is the Security Service Edge offering from Palo Alto Networks.
Okay. So there's a lot of services that are bundled within SASE, and some of those are going to come up as we talk along here. But I think the first point we want to raise is that Palo Alto Networks you guys made this strategic decision that Prisma SASE is going to be built on and delivered from public cloud hyperscalers, the big guys out there. Why did you go that route and not decide to build it your own?
That's a fair question. So we decided early on to focus on our core strengths. I want to deliver network security and focus on the outcomes, what our customers are looking for from a network security perspective, and decided to partner with some hyperscalers to leverage their strengths as well, the ability to reach, the ability to scale. And we made that decision early on, and we went to market focusing on strengths, focusing on the outcomes we want to deliver, and leveraging scale from the companies that are basically building their capabilities to scale.
Yeah, in other words, you're doing the same thing. A lot of enterprises have the same conversation with themselves. Do I build it myself, or do I go and outsource that function, which is not a core thing I want to have to focus on, building and operating a data center to deliver these services? And so, right, you guys want to focus on the security aspects of the product that you're delivering and not the underlying infrastructure to deliver those security services.
Correct. So we focus on security. However, there is a bit of focus on underlying infrastructure so that we do deliver that security in a resilient and performance fashion. However, leveraging the expertise there from a number of companies out there that have this expertise.
Well, right, because and part of this is about scale in that the
Correct.
infrastructure
Right.
has got to be able to scale with you guys.
Yes.
Yeah. Okay. So I want to start getting into nuts and bolts here. Single cloud or multi-cloud? Did you guys go with a single public cloud provider? Or did you go with multiple clouds?
So we went with multiple clouds. We started, just to be fully transparent, we started with one cloud, quickly expanded to a second cloud, and we added even a third cloud in the last year or so. But the decision or the strategy was from very, very beginning with multi-cloud. Obviously, there is a time aspect to it. So we had a number of months in the beginning where we were one cloud, and then we quickly expanded in the very beginning of the service to add a second cloud to address or to deliver that goal with multi-cloud.
Oh, so many questions. Okay.
Go for it.
Well, let's start with this. Can you disclose which clouds you're in? Is that public knowledge?
It is public knowledge. So we partner with AWS, so Amazon Web Services. We partner with Google Cloud Platform, and we recently announced a partnership with Oracle Cloud Infrastructure.
Okay. So not Azure. Okay, but AWS, GCP, and OCI. Interesting. Oh, and this timing is interesting too that we're having this conversation because we're recording this in early November 2025. I mean, last week, I think it was last week, AWS and actually Azure both had massive outages that were very, very public. So, Christian, even the biggest clouds can break. So, is multi-cloud the resiliency strategy? Is that why you ended up as multi-cloud?
It's part of it. So one of our key goals is to deliver a service that is on all the time and on all the time wherever you want the service and with the needed, let's say, performance. And yes, you're referring to a couple of incidents that happened, I don't know, a few days ago, a week or so ago. There are a number of services that rely on either AWS or Azure that were at best experiencing some difficulties, or they were just down for, I don't know, a number of hours, if I remember correctly. And resiliency is part of that. So just to kind of go a little bit deeper into that, we do leverage everything that all these cloud providers are offering from a resiliency perspective, multiple availability zones, multiple regions. On top of that, let's take the example for one of these incidents. There were some outages for one particular region. It so happened it was one of the major regions that they have. However, the other regions were not impacted. So we were able to leverage the other regions. But within that geographical area, we had other cloud providers that were able to pick up that workload for Prisma Access in terms of data plane processing perspective, security inspection, all of that, so that we are not moving the workloads far away from the users. So while you can handle resiliency in so many ways, sometimes if you move workloads far away, you're adding latency. So as the service is still up, which is important, probably the most important thing, if the user experience is impacted, then you may want to look at how you're providing the resiliency to begin with. But to answer the question directly, the resiliency was one of the major reasons to work with multiple clouds.
Even though there's an operational cost to that, that's a whole other can of worms, I suppose. Let's leave that bit for later. I want to talk more about the operational impact because operating in AWS is different from operating in GCP, just from the fundamentals, the primitives of how you're getting done what you need to get done. But let's talk a bit more about resiliency because you said a few things there. One is AWS in this example, that was US East 1 that had problems, but you said you were still able to process in that geographic location for certain of the services, which was a good thing because now we're not adding latency for people that are in that area and need to be responded to from that POP. So you've got separate sets of services then running in each cloud? Is it an exact mirror of services in each cloud?
It varies a little bit depending on which service we're talking about. So I can dive a little bit deeper with US East. Yes, it impacted, I would say, a minor impact for some of our services with Prisma Access that are operating out of US East. In terms of data plane processing, there was no impact there. And we were able to leverage not just, let's say, US East with what was still operational, but also kind of move what was not working well from US East to a different cloud in the same geographical area. But coming back to your question, from a resiliency perspective, one of the main things that we pay close attention to is what we call data plane. Where is security inspection happening? At the end of the day, this is where the traffic flows. If that is down, then users cannot connect to applications. So we pay close attention to make sure that's basically mirrored. Is it the exact same service? No, there are nuances to your point. The way AWS architects their infrastructure versus the way GCP architects their infrastructure versus the way OCI architects their infrastructure, there are nuances with them. So it's not exactly a small feat to make sure that we do deliver the same service across all these cloud providers. From a data plane perspective, we do mirror the capabilities and we scale as needed depending on what's available where so that we can handle the load in terms of number of users, number of applications, number of flows, and all of that. Is it the exact same capability? No. There are nuances with the infrastructure that we're leveraging there. However, in terms of what we want to deliver, what are the capabilities there? Yes, they are the exact same goals or the exact same outcomes that our customers are benefiting from.
You mentioned data plane. is
Yep.
that data plane actually? Is that just like an EC2 instance, x86 more or less, that services are running through? Or is this something special?
We leverage basically standard services from these cloud providers. So we don't necessarily want to have something created specially for us, although we do partner with all of these cloud providers. So we have enhancements that they have delivered in the partnership with us. Those enhancements are part of their standard product offering. So yes, we do leverage EC2 and a number of other services. There are quite a few things that we leverage from every single cloud provider. Yes, there is compute primarily with VMs, but there are other components there as well, things like load balancers, NAT gateways. There are a
Okay.
number of serverless, let's say, services that we leverage from all of them. We're fairly heavy on a couple of key areas. One is compute with a variety of different, let's say, offerings there. It's not just EC2, but in case of AWS, it's heavy on EC2. And the other bigger part is networking. There is a lot of data that we ingest, and there is a lot of data that after we process for security inspection, we either get it to a private application, let's say in a VPC, in a
Mhm.
VNet in case of Azure, or in a private data center, or to a SaaS application on internet. If you want to reach the likes of Salesforce or recording on Zoom or Workday or some other SaaS application, we handle that as well. So a lot of compute and a lot of networking services that we leverage from all of these cloud providers.
With all of that compute, you need a certain amount of guaranteed processing power, I'm assuming. Are you fighting with noisy neighbors?
We do not. So this is something that we decided from the very beginning, just to kind of put a little bit of context there for people that may not know what a noisy neighbor is. If you are leveraging common infrastructure and you're a customer of Palo Alto Networks, and let's say in the same geographical region, in the same area, Palo Alto Networks may have another customer. If these two customers are competing for the same resources, which one takes
Right.
priority? So we wanted to have things a little bit more separated, not just for capacity or infrastructure availability perspective, but also there are some security considerations as well. So what we do for every tenant, for every customer of ours, we instantiate separate projects, separate infrastructure, so that we scale as needed on a per customer basis. That helps with allocating infrastructure, allocating compute, and all of that on a per customer basis. It can be even more granular than that. That's number one benefit. The second benefit is we look at the security considerations. We do dedicate IP addresses on a per customer basis, so we don't share IPs with customers. Why is that relevant? Two reasons. A good number of our customers, and actually not just our customers, in general, companies, organizations out there, they want to use IP allow list to allow or not allow access into their SaaS applications. So basically, they say user Ethan, you want to connect into, let's say, Salesforce or another SaaS application. You can connect if you come from one of these IP addresses. If you're not coming from these IP addresses, you will not be able to connect. That's kind of the basic of IP allow listing. So what we do, we assign IP addresses on a per customer basis. They are dedicated so that if there is anything going on with, let's say, your noisy neighbor, so to speak, that will only be impacting that neighbor. Whatever they do is going to stay within their lane. It will not be impacting you.
Does that so that also means well, does it mean, I guess that's the question. Do I even get as a customer dedicated CPU in the cloud for my my
You get
transactions?
dedicated vCPUs that are exclusively for your use, and we work with our customers very closely for even in the original deployment as we plan to scale per their needs, or if there are some specific events that they need to accommodate, things like all hands or some public events. I want to have an increased capacity in so and so geographical region. I want to accommodate, instead of my usual 10,000 users, I'm going to have 100,000 users. So
Hmm.
basically dedicate that capacity that's going to be reserved for that tenant, for that customer.
Are you hiding me behind a load balancer so that I could scale out with EC2 instances? Are you scaling up my EC2 instances?
We have load balancers typically in front of the traffic coming in, and then behind those we scale horizontally.
Got it. Okay, that makes yeah. That's what I thought you'd say, but
Yeah.
Yeah, but wasn't
It's
sure.
good that I'm not surprising you.
Well, I've had to argue a few things, nothing like the scale you guys do, but yeah, I mean, there's trade off to everything, right? There's trade offs to why you do certain things one way and not another. But scaling out, typically, in my experience, is just a lot more flexibility, especially when it's not going to be that traffic load forever. It's the
Yep.
holiday weekend. It's Black Friday, Cyber Monday, and you just temporarily need a big chunk, and you want to shut them off when it's done. Scaling out is just way better to deal with that. I also like that you're putting me as a customer on a dedicated vCPU, in that again, that noisy neighbor problem isn't there, and I should have pretty predictable latency as I'm flowing through that. I should know pretty much what my latency overhead is going to be as I push traffic through the service. Is that a fair observation?
It is a fair observation. Basically, you have dedicated infrastructure, dedicated capacity, and it's fairly transparent to you. You see our location. We'll talk about US East earlier, right? So US East, US West, Central, Canada Central, Canada East. That capacity is dedicated to you, so that if you are I'm based in San Francisco Bay Area, I usually connect to US West. When I travel to, let's say, East Coast, I would likely connect to US East, so that capacity is reserved for my usage, me as a
Okay.
customer.
Now, you mentioned multi-regional, multi-cloud resiliency. So let me throw a scenario here at you, since the
Yeah.
AWS outage is fresh in our mind. If I'm processing, and it so happens that I'm processing through US East, and now there's a problem and things are going down, how do you shift my traffic over to a different cloud entirely? What happens in that scenario?
So let's kind of break this down step by step, depending on what kind of outage we're talking about. First, we're leveraging from all these cloud providers. There are different terminologies out there, but just to be a little bit more simplistic, availability zones. So independent data centers, independent power, independent cooling, and all of that. If there is something happening with one data center, we basically have hot standby instances in another data center, different availability zone. So that's level one. Level two, those availability zones are typically aggregating into a region, AWS, GCP, OCI region. If something, either a major disaster happens in that geographical area, or there's some software, which is typically what happens, there's some software impact that will, let's say, make some of those services to be impacted in that region, then the entire region is down. So what we do there, we have a couple of options. One, we move to a different region within the same cloud provider, or if there is a different cloud provider that is in the same geographical area, we will move that load into that cloud provider. The reason I mentioned this scenario is not always there is overlap with cloud providers having a presence in the same geographical area. So US East
Yeah.
is one of the places where basically all major cloud providers are present. Once you go, even in the United States, but especially outside the United States, chances are either just one, potentially two cloud providers are there. So that's one of the major reasons we operate with multiple cloud providers. Besides resiliency is reach. So US is fortunate like that. There is significant presence with basically all cloud providers. Once you go in the developed world, that typically tends to will continue to be the case. And as you go into some other places, Asia in particular, but other continents as well, we may have only one cloud provider. So if that region goes down, then we'll leverage the closest one, which may or may not be the same cloud provider.
Okay. And there's a monitoring infrastructure. There's got to be something happening to shift all of these. There's not some human sitting there. There's going to be reassigning DNS entries. It's got to be all automated. So how are you dealing with
Absolutely,
that?
it's all automatic. That's a great question. So basically, the way our solution works, and for that matter, this is how a typical SSC solution works. There is some sort of a piece of software sitting on the remote user laptop, desktop device. That's an agent. It may be a browser. When the agent tries to connect to our infrastructure, basically we determine the closest point of presence that you will connect to, and you establish
Yep.
the connection. Security inspection happens there, and all of that. If that goes down for whatever reason, whether there is a software upgrade or there is a disaster or something is impacting that point of presence, the agent will determine the next best possible location to connect to.
Okay, that helps. A lot of times, architecting applications, if you're coming from the web world, yeah, it sits behind a virtual IP and so on. And well, what if you can't service out of that location anymore? Well, there's some kind of a DNS change that shifts you over to a different region, different point of ingress. I'm not thinking about the agent part of it, but that's right. That's the obvious answer. The agent is the one that's going to be like, "Oh, I can't connect to the thing I was just connecting to," and then we'll figure out from there where it needs to go next. And so your resiliency is happening both on the back end, but then it's seamless because of how it's happening on the front end in the agent.
Correct. And speaking of the agent, with the introduction of Prisma browser, there is an additional layer of resiliency on the agent itself. So things may happen on your laptop, on your desktop. Blue
Mm-hmm.
screen of death, unfortunately, is not a thing of the past. It can still happen. Bad things can happen with other operating systems as well. So if you're usually working from a laptop that is using an agent to connect to an SSE infrastructure, if something happens with that particular device for whatever reason, you can actually start working from another device with Prisma browser to connect into our SSE infrastructure from yet a completely different device. So the agent it's not a mandatory thing. You can use Prisma browser as another business continuity element for the end device, for the laptop.
What if I want to push? What if I want to use either as a point of resiliency or because I have some other data governance needs? I want to push the traffic through a facility that I provide. Is that an option?
As a customer facility that you provide.
Yeah, like a
Yeah,
private. I don't know. Call it a private pop or something like that.
funny that you mentioned that right now because we're actually launching a new capability for yet another layer of resiliency. So I talked about multiple availability zones, multiple regions, multiple clouds. I also mentioned that sometimes in a given geographical area, the next cloud point of presence may be far away. So how do we handle, let's say, northern East Canada, maybe only one cloud provider? I'm just picking a random geographical area.
Hmm.
Well, we're launching something called SASE private location so that in case of resiliency, if cloud services are down or the cloud services in my proximity, geographical proximity are down, and the closest one is far away, 1,000 miles away, 1,000 kilometers away, how do I handle that? And the point of the SASE private location is to provide that exact point, an additional layer of resiliency so that you can deploy it on your premise, in your data center, maybe colo data center, you rent something somewhere or you own something somewhere, you deploy that. It's going to be a managed point of presence. So from a customer perspective, it's going to look and act like any other point of presence within Prisma Access, within our SASE solution, the exact same capabilities, the same policy, the same features. The only nuance would be instead of being in AWS GCP OCI, it's going to reside in your infrastructure, wherever you put it.
Interesting. Okay, is that so? You're extending the cloud to my data center in this SASE private location scheme, then more
That's
or
a good
less.
summary, yes.
Yeah. Okay. Intriguing. But that's it, but is that production yet? Can I actually buy that from Palo Alto Networks today or not yet?
It's buy is a stronger word because including it in some of our packages, so it's actually
Right.
included.
Right.
Today is in private preview,
Okay.
and we're looking at probably in a matter of days to be available for general availability.
Interesting. All right.
I guess it depends
Well,
on when this podcast will be published. I said
well,
a matter of
this
days.
should be published the 7th of November, so
Correct.
somewhere on either side of that date,
Correct. Yes.
if
So
you're
it's
interested in
just
that. Yeah.
within a couple of days of that day. Yeah.
Got it. Got it. Okay. Now, I mentioned data governance was part of why I asked that question and those challenges. Can you control how traffic's being routed around the internet and through these various cloud providers? Are you using their backbones? And how do you deal with data privacy and data governance concerns in that scenario?
Right. So as you probably kind of hinting to, these are increasing concerns, questions coming from all over the world with our customers. A lot of reasons behind that. So number one, we do leverage the backbone from our cloud providers. There are a lot of benefits with that. So I want to come back to that part. However, at the same time, we also offer our customers the option to choose where their data should reside and where how their traffic should be handled.
Mhm.
So just to go a little bit into some, um, let's say, technical details, one of the very first things that our customers will need to do is to select the region, as in geographical region, where their data should be residing, logs, personal information, things of that nature.
Mhm.
And that region means a country. So you can choose United States, you can choose Canada, Germany, UK. We have an increasing number of countries out there. So you will decide as a customer where you want your data to reside. So that's a configurable option, and each customer will have their own, I would say, considerations when they make that decision. So we offer the capability for us to store and process the data where the customer chooses. So that's option number one. Option number two, in terms of how I want my data to be handled, where the security inspection happens. So I talked a lot about having proximity to the user, proximity to the application. Well, that proximity is also configurable so that the customer will choose in their management console, I want my data to be processed in so and so locations. Let's say if there is some sort of public sector organization in Brazil, as an example, they may want their data to be contained in Brazil. So
Mhm.
that's a configurable option. The data will not leave Brazil. Now, just to tie it back to the backbone for cloud providers, we do leverage their backbone. There are a number of advantages by doing that. So it's similar with they say the reasons regarding the resiliency on the compute side. There are advantages of the backbone. There are a number of incidents that happen and continue to happen pretty much all the time. Fibers being cut, undersea cables being impacted. I think there was an incident, I want to say earlier this year with Red Sea. There was an incident a couple of years ago in southern France where some major cables were cut. And if you're managing your own backbone and you have specific, let's say, regional contracts with a variety of ISPs out there, these type of incidents are your problem. You need to handle them, actively handle them. So we're leveraging the backbone from our cloud providers for them to also handle these incidents. So I'll give two examples. One, when the incident in France happened, I want to say it was maybe 2.5 years ago, the impact was minuscule, or the number of seconds, I want to say 5 or 6 seconds, so that the likes of GCP AWS basically shifted to a different route, so the traffic
Mhm.
is not impacted. And the other example is today, if you're needing to reach an application, an internet website, a SaaS application that may be hosted on the other side of the planet, that's not in your control. And we'll leverage the backbone of these cloud providers, and they will have direct peering relationship basically with vast majority, if not all, major ISPs out there.
Yep.
Why? They are major content generators. The YouTubes, the Netflixes, the Zooms of the world, they are hosted on the same cloud provider. So in terms of how majority of internet traffic goes, it goes through those backbones as well.
Yeah, and I would assume most people know this, but the some of the major fiber networks in the world, it's not just a bunch of tier one internet providers that are interconnecting to each other with fiber. It's these folks, these cloud service providers have massive
Right.
fiber networks that are global. And depending on their routing policies and what they prefer, they can keep their routes, keep their traffic all internally to their own. It never really hits a different provider. It's all going across their own fiber. Or
Yeah.
some of them handle that a little bit differently. But more to the point is the number of, the thousands and thousands of miles of fiber that these folks maintain for their own network routing, resiliency, latency, and so on purposes. So
Yeah.
completely understood what you're doing there. Yeah, but okay, well, that in mind, do you have any of your own fiber? Does Palo Alto Networks do any? Do you have any of your own fiber that you use for any of this?
No, we do not. So
Okay.
we have our own agreements with the likes of AWS, GCP, OCI, and we tend to contract their premium offering from backbone perspective, make sure that we have capacity needed that we need for our customers, the right SLAs, the right reach, the right peerings all around the world. And we can actually go a little bit deeper into how the peerings are let's say contracted or achieved in so and so country on the other side of the planet. So we leverage their reach to
Mm.
deliver our service.
Now, you mentioned earlier we were talking about how the different services are actually deployed from a cloud primitives perspective. There's virtual machines, you use some serverless, and so on. Now, I'm thinking about this from a firewall perspective. If I was running this myself on a Palo Alto Networks box, it's going to be a firewall. It's probably got some custom silicon in there to accelerate certain functions and all of that. I think of it as special. That piece of firewall hardware is a special quote unquote device. Well, how do you accelerate functions in the cloud like you would on a box with your own branding on it that's maybe got custom silicon inside? How do you get the performance and scale that you're looking for?
Great question. So a number of things there, but one thing I want to call out. Um, First, when I talk about firewalls in the cloud, I think there is a bit of um, folklore out there that some services are just, hey, you take a firewall, you put a VM, this is software, and just put it in the cloud, and you call it a service.
Well, because the earliest days, especially from a network engineering perspective, that is a lot of what you had on offer.
Right.
I got this router. Now it's the same thing, but it's a cloud router, and I fire it up, and it looks and behaves the same way. Wasn't especially efficient. Wasn't a very cloudy way to do things, but it's what we had early on.
Yeah.
But your point is that is not what we're talking about today.
That's not what we're talking about. And there are a number of security services that even for firewalls are delivered from the cloud. So our cloud delivered security services, things like advanced URL filtering, advanced threat prevention, Wildfire, which is our sandboxing solution, DNS as well. We run all of those majority serverless in cloud to begin with. And our firewalls, and this is not talking about our SSE solution, are leveraging those security services in the firewall. On the SSC, this is going kind of to the next level. We're leveraging those cloud delivered security services as well. So we're calling those out. But even for security inspection that is happening in SSE, yes, there is a VM component there. But on top of that, there are a number of other services that are being added. I talked earlier about load balancing. I talked earlier about NAT gateway. Going even deeper when we connect, let's say, a remote office, factory, branch somewhere. We actually separated the networking, as in where the tunnel terminates. You have the office connected to a tunnel to our service where the security inspection happens. So those are two different type of nodes. We terminate the tunnel, we scale that vertically and horizontally. And then behind that, we also scale vertically and horizontally for security inspection. And where security inspection happens, we call a number of security services like DLP as an example from that, let's say, instance to do data inspection and data loss prevention on that node. So kind of how to try to put everything together. Yes, there are some VMs out there, but on top of those, quite a few other services. And when we talk about security, a good number of those security services are delivered from the cloud, even for our firewall customers. So the firewall itself is calling out sandboxing, is calling out URL filtering, is calling out threat prevention. Yes, there are signatures that are being delivered, but also in terms of how do we prevent day zero type of attack, how do we inspect inline an URL never seen before, that's being done in the cloud as well.
Okay, so everything's been broken up into, I don't know if it's fair to call it a microservices architecture. It feels a bit like that.
Correct, yes.
Okay, so one follow-up question about the serverless side of it. I'm a little surprised that you guys can leverage serverless as much as you are, in that the instantiation time for serverless, I feel like that's something for a smaller sort of a function, but the inspections you're describing seem like there'd be more spin up time just to get it going. I'm just going off my gut here, and obviously I'm wrong. But clearly you can, with serverless functions, fire up an inspection requirement on the fly, do that, inspect that. What would it be? A flow, presumably, and then shut that serverless instance down. They're fairly short lived.
For some aspects, yes. For deep security inspection, it's not serverless, but for some aspects, yes, we do have some Lambda functions and other things out there. And they operate in that sense. Spin them up, we're done, spin them down. For deep security inspection, where decryption may need to happen in the middle, that's done with some variation of server with some services attached to that.
Okay. I want to talk about operational impact of multi-cloud. If I'm interacting with AWS, it's not the same as OCI or as GCP. There's different APIs, different ways of enforcing security, and so on, different models. They're not the same. How the heck are you guys doing that?
So this is where we actually spend quite a bit of time on making sure that what we develop and how we develop is as much as we can develop in like that to be cloud agnostic. And this is where we partner very closely with these cloud providers to make sure that what we consume in terms of features, services, offerings from them are fairly not necessarily common, but available to a certain degree from all of them. So
And
if
just a
yeah,
quick observation is that, yeah, if you stand back and at the 10,000 foot view look at what the different cloud providers are offering, there are a ton of similarities there. And so, to your point, you're looking at leveraging the kinds of services that are more or less common from cloud provider to cloud provider.
that's step one.
Okay.
Step two is even the ones that are not common for a variety of reasons, but point in time in terms of development or the architecture is different. We work closely with these hyperscalers, let's say, to make sure that the outcome at least is the same or very similar. The way we get to that outcome may be different. So there are nuances and some differences in how we develop or how we integrate with AWS versus GCP, GCP versus OCI, and so on and so forth. I'll give you one example there. Um, we are working very closely with all of them to deliver an end-to-end IPv6, let's say, compliant or compatible infrastructure.
Mm-hmm.
And I'm giving that example intentionally because there are nuances in how all these cloud providers are implementing IPv6 and where they are in their journey to adopt IPv6 in
Yes.
a
Yep.
variety of different components. So the good news is we have a very successful partnership with all of them. So if there is something, let's say, in some type of load balancer that we're leveraging that is not yet compatible or doesn't have yet IPv6 support from cloud provider XYZ, we work closely with them to arrange how this can be delivered in so and so many months, quarters, or whatever it is, so that we can leverage that for our customers. So, in a nutshell, we do develop and maintain our service to make sure that it's as much as possible cloud agnostic. That's number
Mm-hmm.
one. Number two, when we introduce new capabilities, we make sure that as we introduce them, they are introduced almost simultaneously or being very similar across all these cloud providers. That also means that we need to have, and we do have, successful and productive partnership with all these cloud providers so that if there are some gaps, some differences here and there, they work with us to deliver or to have that feature available in their offerings too. So I give you the example of IPv6 because there are, if you look at their offerings, there are nuances there, and
Yeah.
some of
Yeah.
those nuances are quite important.
Well, I was chuckling a little bit. One of the cloud providers I follow with their IPv6 deployments is AWS. There are announcements coming out every so often of now this service supports IPv6, and
Yep,
here's the kind of IPv6 that this service gets you. And there's a whole blog post that'll explain that.
right.
That is quite nuanced, but far from ubiquitous, as you say. And also, as you say, every provider's in a different place on their IPv6 journey. And so, right, you can't assume just because it's in one place, it's going to be in another. But what's
Correct.
also intriguing is that you guys have the clout to say, "Hey, we're looking for this feature, and we want you guys to deliver that. Can we get it on the roadmap?" And they'll work with you to make that happen.
We have quite successful partnerships, and the reality is our customers, they tend to be common customers with these cloud providers as well.
Mm.
So it's typically not just us asking for a certain capability. Um, uh, there is quite a bit of overlap with the customers that we serve versus the customer that these hyperscalers serve as well. So it's not like we're the only ones asking, and then therefore IPv6 will happen in so and so service. Similar ask is coming from a number of other customers as well. Their customers, as in hyperscaler customers.
And maybe you can answer this one, and maybe you can't, but I'll ask it anyway. From a DevOps perspective, if I'm dealing with, I'm Palo Alto Networks, and I'm dealing with spinning up and spinning down services and so on in AWS versus GCP versus OCI, is there some abstraction layer tool that you guys are using, like Terraform or some such that allows you to deal with infrastructure as code in a uniform way, or do you deal with each cloud specifically and uniquely?
No, we do have abstraction tools so that we can automate all of this. One thing that we're investing heavily in is to make sure that we operate at scale. So we serve millions of users out there. We serve thousands of customers pretty much all over this planet. And we have, I would say, a fairly sizable DevOps teams, however, small enough that we can still count them. And we do have a presence to basically cover all time zones, so kind of follow the sun from a support perspective. But specifically from DevOps, how do we orchestrate our service and all of that? It is done within an abstraction layer so that we can operate these multiple clouds in an automated fashion. We invest heavily to make sure that we automate pretty much all the various activities that we have, not just DevOps, but troubleshooting as well, and all of that to minimize human interaction, not just for minimizing human interaction as in a goal in itself, but also how do we provide the scale that we need. Again, we're talking about thousands going into tens of thousands of customers, millions of users, pretty much anywhere on the planet.
I would have been surprised if you given me a different answer. That aligns very well with the previous topic we had about the kinds of services that you're leveraging across the cloud service providers. It all lines up. I don't know how else you could have been doing it, so it makes good sense. All right, Christian, I got a question about telemetry.
Yep.
The amount of just the volume of it. It's boggling my mind trying to get my head around how much telemetry you guys have to be ingressing and doing something with. So is there a strategy around that you can talk about?
Telemetry has been top of mind for us for quite a bit of time now. And it's one of those things you never have enough. So we're generating a ton of telemetry, most of that being offered to customers as well for a variety of, let's say, visibility type of aspects into their infrastructure or how their user experience is or how the application experience is and all of that. And this is a good example where we actually partner very closely with one of our cloud providers to make sure that number one, we generate that an increasing amount of telemetry. Number two, from an ingestion perspective, how many logs we can ingest on a per second basis, even beyond logs, what kind of additional telemetry we generate from our infrastructure, not just to provide visibility insights to our customers, but also to have pretty much as much automation we can have to detect when things don't work as they are supposed to be working, so that we put automated playbooks to remediate those.
Mm-hmm.
I mean, we talked earlier about some cloud providers having outages. Obviously, we do monitor that, and we have some site reliability engineers that are monitoring all of this. However, the best way to do it is have everything automated. If there is an incident in so-and-so region, some of these services are being impacted, we trigger an automated playbook to handle that, including and not just limited to, we notify our customers, hey, we see this incident, we're looking into, and this is the remediation that we applied when that is there. But to go back to telemetry, I think I was looking at this earlier this year. I think the amount of telemetry we're generating now, I think increased exponentially in the last year or so. I forget the exact multiplier. It's not 1 point something, is a larger number than that just in the last year. And
Because of more customers that are leveraging the service, you mean, or some other
this
reason?
is just one of, if you normalize by number of customers, number of users,
Okay.
generating more and more telemetry. Obviously, our service is being used for more use cases, so that's one aspect. But the other aspect is we're trying to generate more and more data to not just monitor if the service is operating as it's supposed to be operating, but giving insights into, and I think user experience is a good example, how the user experience is. So if you're connecting, you're talking earlier about application, you're connecting from your home into our service, into the application. How is that experience actually perceived? And we're trying to monitor every single hop there, every single aspect. And
Including which you can from the agent perspective, you can get right down to their Wi-Fi at home, if I remember right.
so looking for getting telemetry from the agent. I'm working from home today. I'm connecting to my Wi-Fi at home. So the agent will report back into Palo Alto Networks, Palo Alto Networks IT, that whether my Wi-Fi is good or not good, my internet service provider is good or not good, my internet connectivity is good or not good. And as we ingest the traffic, we monitor our infrastructure node by node, but also session. I'm connecting over Zoom right now. How this Zoom, let's say, meeting is going hop by hop all the way into the application itself. So we're connecting all of that data, benchmark it, and see versus how it's supposed to be, put a score there, and we present back to the customer and to the user if the user is impacted. This is how the experience is. If my Wi-Fi starts to be flaky for whatever reason, then I get a notification. Your Wi-Fi is not working as it's supposed to be working. So that's all collected from a telemetry standpoint. And our customers will decide whether they want to expose some things to the end user or not, so the user will get a notification or not. That the second part is all configurable, but the telemetry needs to be there to begin with, and it's just an insane amount of data. And if anything, we're not slowing down; we're adding more and more, which brings us to kind of the second part. Data for the sake of having data is not very good. So we're putting a lot of models on top of that. How do we analyze it? How do we make it actionable so that one, we provide a better service, and two, our customers will get more insights from our service as well, not just regarding to our service, but regarding to their user experience, application experience, and all of that.
You said model, which is a bit of a trigger word. Are you talking about simply statistical analysis of the telemetry that's coming in, or are you actually throwing machine learning at it to come up
A
with some of
lot of
the
machine
analysis?
learning, even large language models for certain types of data.
Yeah.
And this goes into what I think you asked me some in the very beginning with data sovereignty. So
Yeah.
in terms of personal data, that's obviously not part of any training models and all of that. And where data is residing still is according to what the customer chose. If you chose United States, the data will stay in United States. However, there is a lot of machine learning applied on top of that to determine whether, again, looking back at user experience, whether user experience is good, fair, poor, and that's basically that benchmarking is dynamically adjusted depending on what the situation is at that point in time. So yes, there is a lot of machine learning applied on top of that.
Then going back to our discussion about cloud service architecture, cloud service provider architecture that you're relying on, do you have to partner with them in some special way to be able to handle all of the ingestion? And does the data that is being analyzed with machine learning and so on, does that also stay in the cloud? And is that a cloud provider service that you're taking advantage of?
So we leverage services from our cloud providers, and we did partner closer with some of them to make sure that the ingestion rate, the type of load that we generate is scalable and we can handle that. So the reality is some of those off-the-shelf services, they need to be beefed up, I don't know how else to say it, to make
Yeah.
sure that the load can be handled.
You could have network a certain amount of load per second. You need to have be able to write to disk, etc.
Correct. But that was done in a, I would say, programmatic way. So it's not a snowflake done specifically for us. It was done in partnership with us, and the entire service actually benefited. So as we work with these cloud providers, their service got better to handle the scale that we're talking about. But it's not just offered to us. It's basically that the service got or it was improved in general.
Okay, a few more questions for you. We're getting to the end
Go
of this
for
thing,
it.
Christian. So if you're getting tired, we're almost there, almost home. Going back to data sovereignty a little bit. So a little different angle on the question is this. If I'm fussy about which cloud service provider my data lives in, can I tell you yes AWS, no GCP, something like that, or is that opaque to me where the workloads are running?
It's fairly opaque. So we're transparent in terms of we're using these cloud providers. However, what we use from every single one of them, that's a bit of our intellectual property and which
Hmm.
services we operate from where. There are a number of
Okay.
considerations there. However, from a customer perspective, we offer our Prisma SASE service. And that can be instantiated in some parts of the world as a primary provider being, let's say, one of them, secondary being a different one. In other parts of the world, maybe a different approach. So from a customer perspective, just to be more direct, it's opaque in the
Yep.
sense of we provide our service, and in the back end, we choose the best option that we have to make sure that our service is one operational and to provide the best possible experience.
Okay. Another operational question, kind of. Sorry that we're getting to the end of these like these oddball things that have popped in my head here.
Yep.
But one is about lock-in. one of the complaints, or not complaints, but concerns that anybody has working with a cloud provider, really any vendor, is that of getting locked into the specifics of that vendor. Now, the way you've described it, it sounds like you're a bit removed and don't have that concern, especially. But I wanted to ask anyway, is that something that's on Palo Alto Network's mind as you deal with these cloud providers, that you're going to get locked into using them?
Absolutely is a consideration. That's, I would say, one reason why we develop our service to be as much as possible cloud agnostic. So that it's not just the resiliency aspect of it, but locking to a certain degree so that we can operate the service from basically any cloud provider out there. That doesn't mean that there is no work needed. There is some work needed. We try to minimize the work from a development perspective, testing perspective, maintaining perspective, all of that. And we do as much as we can to be agnostic, but there are nuances. The way I think I mentioned earlier, the way load balancing works in AWS is slightly different than GCP, slightly different than OCI. And if you look at other cloud providers, Azure and whatnot, there will be differences as well. However, we try to abstract that so that as we offer our service to the customer, they see one service, and what's behind that, it's going to be a little bit of on our side to make sure that we provide a consistent service. And if there is a need for us to change one cloud with another cloud, let's say a resiliency type of business continuity type of a scenario, we can do that with no customer, or I shouldn't say no, minimal customer impact.
And then I got one about scale. You've described scale out architecture. And
Yep.
from most of us, when we look at a cloud provider like AWS, we go, it might as well be infinite resources because for all practical purposes, it is.
Yep.
At your scale, it isn't an infinite pool of resources. I suspect that maybe you actually hit scaling limits. Is that, or have you? I guess that's the question.
So far we haven't, so that's a good thing. However, we don't let this to chance. The way I think about this, nothing is infinite in this world, other than maybe the world itself. So there will be limits. They tend to be very high, and we work ahead of time with our partners, and we give them sufficient visibility into how we look to scale capacity in the next 3, 6, 9 months, maybe a year or so, so that we don't hit limits. We haven't hit any so far, but on the other side, we tend to be fairly, I would say, conservative, and we look at, hey, what we're seeing, what we need to see, and let's make sure we don't hit those limits. I'll give you one example. One of the things that COVID brought us was the ability to work from home, and it pretty much happened overnight.
Yeah.
All over the world. Maybe the nights were different, but it happened overnight. And even at that time, we had an aggressive increase in remote worker type of scenarios. And even at the time, we didn't hit limits. However, it wasn't just left to chance. So we work closely with our partners to make sure that they have visibility in what our needs are. So we have sufficient capacity, US East, or I don't know, Canada, or Singapore, or UK, or whatever we're talking out there, so that there is no surprise that, hey, we're going to onboard 1 million users tomorrow.
Right. Okay.
And when we have large scale, which we do, changing the load by a couple of percentage points means a fairly large number. However, we do have, let's say, visibility into that to make sure that we don't hit any limits.
Christian, fantastic discussion. I have enjoyed this. I have even more questions we could get into and some deeper nuances, but for now, I think this is a good place to stop. Now, are you on the internet? If people want to dig into some of this more, maybe they got more questions, how can you be found?
Yeah, absolutely. I'm on LinkedIn. So my name is Christian Raducanu. I think there are a couple of others like that. I'm the only one working at Palo Alto Networks. So if
Okay.
you search for my name, Palo Alto Networks, I'm the only one.
Okay, Christian Raducanu, thank you very much for being on Heavy Networking today. And there's some blogs up on the Palo Alto Network site, by the way, that cover some of this. There's a blog in their SASE blog section, the architecture behind Prisma SASE, and so on. And we'll link to those in the show notes at packetpushers.net for this show. Again, this is Heavy Networking, and search for Palo Alto Networks. They've done a lot of work with us over the years, but you'll find this as a show we published on November 7th, 2025, and find some more links there. And then, of course, the Prisma SASE webpage you can land on and dig in from there. Tons of resources that's your gateway to get there at the Prisma SASE webpage. And thanks for listening to Heavy Networking today. All of you very much appreciated. One of my goals with every episode is to share how other people build their networks. And yeah, I know. I know most of us are not operating at the scale of Palo Alto Networks, right? But you can still learn architecture principles that inform your design choices no matter what size your network is. And if you were listening to what Christian said and how they handled certain situations and managed trade-offs, there's a lot of things you can pick up about, like the way they're doing their abstraction and how they design the service so that when a certain availability zone goes down, they can come up in another region, and how it's all transparent to the end user. And those are all things you can pick from and learn from and go, oh yeah, we could do things a little different, even though you and I are going to be operating at much smaller scale. Now, if you ping Palo Alto Networks about Prisma SASE or any of their fine security products, would you let them know that you heard about them on Packet Pushers? That is one of the very best ways to let them know that the work they do with us is reaching engineers like you. And we do thank Palo Alto Networks for being a Packet Pushers sponsor. You guys have been great for a lot of years now, and we really appreciate it. I've been Ethan Banks. Connect with me on LinkedIn or the Packet Pushers Community Slack group, which you can join for free at packetpushers.net/community. That community keeps growing. There's more you joining every day. There's over 4,000 people in there. And if you haven't checked in there in a while, we've broken up into a bunch of different channels. There's a firewalls channel now, for example, campus networking, Linux networking, and so on, and many great conversations happening in those different channels. And while you're visiting our fine website, you can check out everything else we've got for you free of charge, no login required, respecting of your privacy. We got many more podcast series by and for fellow engineers, researchers, and industry analysts. We've got newsletters, our YouTube channel, and so on. All the things, packetpushers.net. Last but not least, just remember that too much networking would never be enough.